Do you want to know the best way to write code to count parts at the end of the line? Counters in the PLCs are the unsung heroes that ensure precise and efficiency in industrial automation. Hello and welcome back to ReddyControls YouTube channel. If you are passionate about automation and control systems, you have come to the right place. Today we are diving into the world of PLC counters. These little tools play a huge role in keeping our automation processes run smoothly. In this video, we're going to talk about 3 different methods to count good parts produced at a production line. So without any delay, let's get into Studio 5000. As you can see, here is the program that I used in the last video, and that last video is about how to use timers to make a flashing green light. If you want to review that video, the link will be shown up in this video. Just going through this program again, we created a self-timing timer and we used the accumulator bit to count for 1 second, and we use that 1024 milliseconds to turn on the green light. And we also have a flip-flop flashing timers to create a flasher here for every 3 seconds. Okay, now imagine you have a photo eye at the end of the line that's going into the downstream process. We consider that as a green light, as a good part. So we'll go ahead and just create a temporary bit, and we will use the light 1 green as a indicator for counting good parts, right? The first method we're going to use, the simplest method is the first method, which is using the compute and math instruction called add. And we'll just go here onto the top, compute and math, and select add and drop it in this line. So all we're going to do here is create a tag called gparts using addition, and we'll just call it a dint and create. And every time the green light is on, we want to add a 1 to it, and we want to store that back into the good parts underscore add. Okay, the one thing you're going to see when I install it, when I assemble this line, our gparts add is incrementing in thousands, right? That's because the add instruction is counting all the time when light 1 underscore green is on, right? In order to make this a event based count, we want to use an instruction called one shot, ONS, right? And ONS instruction makes the remainder of the rung true each time the rung in condition transitions from false to true. So let's add that. We call it a gparts underscore add underscore ONS, and we just create a new bool. So all this one shot ONS does is every time the light 1 green goes from false to true, it will make sure we add only 1 to the good parts, right? So just to see it, if I make this 0, every time the green light comes on, we add 1 to the good parts. Okay, in a similar fashion, let's create one more rung, but this time we will create a bad parts. In here we just use the red light as a photo eye which is on the reject lane, and we just call it a g parts reject parts underscore add. Okay, create new, and we'll just create a new tag called reject parts. And we add 1 to the reject parts every time the red light comes on. So far we just created 2 tags. One is to count the good parts, the other one is to count the rejected parts. And to find out the actual parts, we just need to subtract good parts minus reject parts. So we could insert sub, that will fill up the subtract. Again, all I do is insert and then type sub subtract, or you could go to the compute math and get that. And all we're going to do is good parts would be source A. I can drag from here, and wherever your green circle is, just drop it there. It will do that. And then I'll take the reject parts and drop it into source B. And the destination, we say final parts. Okay. And we create new tag called final parts. Okay. And we go ahead and finalize all edits in the program. So that's it. Method 1, all we created is we took the light one green in my example, but it could be a photo eye or a proc switch at the end of the line which detects a part, and we added 1 to the good parts tag. And similarly we used a proc switch or a photo eye on the rework line or a reject line, and we added a 1 shot for both, and we added for the reject parts add 1 every time the red light comes on. And we subtracted good parts minus reject parts is equal to final parts. So this is our method 1 instruction. Method 1 instruction is simpler, easy to understand, but things to watch out here are we had to make sure we use 1 shot ONS, and any resets or any reset logic you had to consider it case by case, but this is the simplest method to count. The second method we're going to talk about, same logic. We're going to have, we just copy the light one green. We will use a counter up instruction, okay, CTU counter up instruction, and we'll just call that good parts CTU, and count up instruction counts up every time the input condition goes from false to true, right? And it increments the accumulator counter every time it counts. So we'll just put 500 as a preset here, and let's go into monitor tags and look at the good parts. So the counter instruction set has a preset that we set up and an accumulator bit that counts up every time the input condition goes from low to high, and the CU bit becomes true every time it detects the condition going from input condition going from false to true, and then the done bit will come on every time the counter is accumulator value reaches to the preset. We'll talk about the overflow and underflow later. Overflow is just if the counter exceeds 2 billion, 2 to the power of 32, the big 2 billion number, it will overflow and set the flag high, and if it underflows to negative 2 billion, it will set the underflow flag. Okay, so we'll go ahead and assemble this line, finalize the edits in that one. Now we have a counter which is counting the parts. Okay, so just to see this in a visual manner, we could either go down to monitor CTU, or we could do a trend. You could see that preset is 500. We are counting every time the instruction is going in, green light coming on and off. So let's trend this just to see. We'll trend this one along with good parts CTU, chart properties, pens, good parts, I think good parts CTU, the accumulator value of that. So let's make this big, see that, okay. Good parts underscore CTU add, okay, and y-axis we will just put them on a separate isolation here, apply, and on the x-axis we'll make it 2 minutes to see it, say okay, and we run. And now you could see every time the light 1 goes from false to high, false to true, my accumulator value should increment, but it's not incrementing. Let's see what's happening. Okay, I used the wrong, it needs to be G parts underscore CTU. I used the wrong tag, so we'll stop this. That was a counter from a previous. So we'll go back to pens, delete that, and we add G parts. Sorry, CTU, good parts CTU dot accumulator, add, okay, apply, okay, run it. So now you can see every time the light 1 goes from false to true, we are counting the accumulator bit. The PLC is updating the accumulator bit. Okay, that's one way to do the good parts. Now in similar fashion, we'll copy paste and we'll just change that to light 3, and we'll change that to a R parts CTU, and we'll create new tag, new CTU counter. We'll go ahead and run that. We'll just make the reset to 0. So now we created a red light or a bad parts, reject parts CTU, and every time the red light comes on, we count the rejected parts. Okay, and we use the same logic. We take the rung 8 and we do a subtraction of, this time we'll take the G parts CTU dot accumulator minus the R parts CTU dot accumulator, and that will give the final parts underscore CTU. We do new reint, and we finalize all the edits. Okay, so that's method 2. Method 2, we used two CTU instructions. The trigger for the first one, the event for the first one is green light, and the second one is the red light, good parts, rejected parts, and we used a simple math instruction, subtract. We subtracted the accumulator value of good part CTU. We took the good part CTU accumulator and subtracted the rejected parts to give us the final parts. Okay, that's method 2. Now we look at method 3, which includes using a, we'll reuse the same logic. We'll just copy paste those 2 rungs, but this time instead of using 2 separate CTUs, we're going to use a CTU and a counter down instruction. Counter down instruction, it does the opposite of counter up, which every time the input condition goes from false to true, it will count down, right? To make it easy, what we're going to do is, instead of using two separate counters, we're just going to use one counter instruction called final parts underscore final parts underscore one. Just right, we create a counter called final underscore parts one, and we create that counter, and now we use the same instruction, we use the same tag, and we count it down when the red light comes on. So the biggest advantage of this method is we don't need to use any other math instruction. Doing this way, we'll go ahead and reset both of them, reset the final part. So doing this way, all we created is every time the photo eye on the downstream process counts a good product, we count it up, and every time our reject lane counts a part, we count it down. So that's the method 3. Let's revisit all the methods. Method 1, we used good parts, we used add instruction, we used the green light with a one shot added to the good parts, and then we used the red light with a one shot, created a reject parts tag, and we subtracted good parts from the rejected parts from the good parts to get final parts. The second method, we used two CTU instructions with two separate instruction tags, two separate tags, G part CTU and rejected part CTU. And the third method, and then we subtracted in the second method. In the third method, we used one tag called final parts underscore one, and we used a CTU instruction to count it up, and we used a counter down instruction to count it down. And we also talked about the reset. We will show you the reset for an example. Whenever this value becomes 2 billion, I forget what was that, just a minute, 2 billion 134, 2 billion 147. So when the accumulator becomes 2 billion 147 483 647 is when the overflow flag will be set up. Let's monitor in the final parts 1, and you could see the overflow flag is set. To reset that, once it overflows, it will start counting in the negative direction. To reset that, we just need to use a instruction, reset instruction. We say reset, and we could use a instruction greater than or equal to instruction, GEQ, and we'll just use final parts dot ACC greater than 2 billion. Yeah, 2 billion. Once we do that, that should take care of the reset condition. Right now it's negative, so we can just use OR condition, So that should do it. That should reset the counter when it goes overflow. So if we go look at the overflow flag, as you can see, the overflow flag is now 0. That's it for this video. We talked about 3 different methods to create a logic to count the parts. First method was using add instruction. Second method was using 2 counters, and the third method was using just a counter up and a counter down. In summary, counters in PLCs are essential for accurate tracking and automation efficiency. Understanding and using the right type of the counter for your application makes a significant difference. And remember, counters are often more reliable and simpler to use than add instruction. If you found this video helpful, check out more PLC programming tutorials on our channel. Don't forget to subscribe and share your experiences with counters in the comments below. Bye.